in order for it to keep looping, there has to be all the counter things acting. And the whole collection of our minimal universe is required for just one piece to happen. It's a very complex gearwork system because it's cascading the scales, right? But yes, I'm saying if you do form the one, then the rest should come too. Yeah.
Oh.
Okay.
I see
so
what you
the big
did
point
there,
is
sir.
that's saying that at the base, we have to go through 10 possible things. There's a string of 10 that loops. There's a base
That's
10
basically the
written into the
explanation
balance
for the
of this double
basically the
cover at the
powers
bottom,
of 10
because
and the
it's
whole
ultimately
Planck constant
creating
and
5
stuff.
bases, but it has the other restriction of being self-closed.
But the
So the
reason
5
I'm
bases
playing,
have to
I
be
probably
used
actually
against
shouldn't have gone
themselves
back
to
this far
repeat
for my whole
and
point
repeat and
here.
repeat.
But
So this gives us a
yeah,
distinction of
basically
base
we
10
go
fingers.
through.
Scale it's already in 7, and we're going to put it the grid that closes 10.
Oh, it went back. Oh, I reloaded it. Yeah. That's what. Wow, I am so freaking bad. I didn't even. Here we go. Yeah, here's a list of all the different stuff and things. Electronvolt. That's basically right over there. That's okay. It's we'll get into it in a second because you all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper Rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyperrulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Yes, I know. Yes, you gotta love the good old cold intro links there, because it's like, I need to readjust this. I'm on the right part, and then you get the refresh, and it's like, oh look, we go back like 30 minutes, and it's okay. It's linked in the doobly-doo. But today, we're talking about the Electronvolt. Yes, yeah, that's actually like, apparently according to Mashable or whatever, yeah, that's supposed to be like a lightning bolt that like spread like 3 states or something. It was really freaking big. But the Electronvolt, it's what's energy and chemistry. At least that's what Wikipedia was telling. It says physics and everything, but it's not SI. The joule is apparently SI. It's basically like 1 over it. We'll get into that tomorrow. But okay, what do we got here? All right, the Electronvolt in physics. An electron volt, symbol EV, is the measure of an amount of kinetic energy gained by a single electron accelerating from rest through an electric potential. The electric potential difference of 1 volt in vacuum. When used as a unit of energy, the numerical value of 1 eV in joules is equivalent to the number value of the charge of an electron in coulombs. Symbol C. Under the 2019 redefinition of the SI-based units, it's 1 EV equal to the exact value of 1.602176.634 times 10 to the negative 19 joules. That's pretty small. Apparently, I hear around the greater science community that might be within the range of a potential neutrino or something like that, the potential mass. Because he uses like mass, you look at Wolfram, it's like, that's like an electron volt. That's a thing that we can measure to the best of our knowledge. But, okay, so the number for the electron volt, it's right there. It's just peeking at us right there. So they set this basically kind of like with the speed of light, other things are like, we're going to redefine it. What do we know really well? We know the electron volt pretty well. So we're just going to cut it off at that. We're going to cut off the error bars. Why? If we're going to use SI, we want a coherent set of units, right? That's the whole point. At least that's what I hear. Okay. So the claim is, and Thad had just put this on that video we were just going through there. Boom, right over here. The electron volt, EV. And we use our standard universal binomial factorization equation. What's that? It's basically your primary action, in this case, Joe1, times the boundary condition. This would be the Planck charge, U sub P here. And we multiply that by the terminal action, So it's typically usually around 7 decimal places, give or take, or so. Kind of things start getting a little wonky there. I'm not saying that's one of the reasons they may have had to redefine SI, but we'll see. We'll see. No idea. Okay. So our terminal action here, again, it's 1 plus or minus the action itself times the the terminal inversion. Basically, because if we're going to be doing a model based off of the hyperbolic figure 8 knot, the Gieske manifold, they have a Kleinian structure built in. There's a point of inversion there. That's the claim, to the best of my understanding, at least. In this case, it happens to be 1 plus e, the base of natural logarithms, raised to the negative Euler-Maccheroni constant, divided by 6. Now, again, the 6, I don't know. I'm just saying where we. Oh, too far. No, not far enough. Well, basically, we have our circle. Oh no, he's going into the Hoppian stuff. It's very interesting. Okay, basically those 6 circles around there again. Just a thought. But okay, let's divide it by 6, and then we're multiplying that by j theta squared. What the heck is a j theta squared? Go to our friend Wolfram alpha. Again, links in the doobly-doo. This is a hyperbolic vortex equation. So that first term, that j1, that's this right here. So j1, right there. And then in order to get that, we take j theta, which when we go down to the solutions of the hyperbolic vortex equation, we can set it to trig form. Basically, we take the positive magnitude of this. Because basically, if you're looking at the little graph over here, these are the same things. Theta is a measure of rotation. So basically, you just take the magnitude of that. That's 2.03, yada, yada. We square it, and then we multiply it by the inversion boundary, which is the final power of the terminal action, which happens to be the Planck mass times the Planck length over the Planck charge squared, which happens to come out to be precisely 10 to the negative 7. I know Rick had brought that up in the chat the other day, or in a comment to one of the videos. He's like, maybe you should discuss the 10 to the negative 7, 10 to the positive 7. Need to learn some more about some of those other things, but it is very interesting. Even me, those words that's coming out of my mouth right now, it might be clarifying a bit. I see why Professor Wolfram does those live streams. Okay, so that's the claim. That's the claim. Okay, what's the actual thing again? The links in the doobly-doo, friends. So okay, type in this crazy monstrosity. It's not as bad as some of the other ones, just because I like using a lot of it. But okay, so as we can see here, this was that number we had over here, right there. Oh. So we take our J1, we multiply it by the Planck charge, which there's a video in the I created the Planck units list playlist, so should be there if you want to go through it. So we multiply it by that, and then we have our terminal action. So a primary action, J1, a boundary happens to be the Planck charge. Terminal action is 1 plus Euler, e, the base of natural logarithms, raised to the negative Euler-Maccheroni. Wow. Leonard Euler really, he did a lot of stuff. I see why I give him a really big shout out in 44. We have that divided by 6 times j theta. That's the magnitude of that. Our basically angle right here. Basically, this is the magnitude. Excuse me, the magnitude that way. Derp. But yep, you got that there. And that's squared. And we multiply by 10 to the negative 7, which basically you can divide by 10 to the 7. This number over here. Now, at least according to CoData, the number we are looking for is 1.602. 1.602. 176. 176. 634 times 10 to the negative 19 joules. And we're listing this as exact. We're cutting it off. We're setting the bar right there. We have a high degree of confidence to the best of our measurements at this time. Okay, so it's 634. 634 2 2 0 2 1. Oh, that number is below a 5 times 10 to the negative 19. That's pretty neat. My friends, this appears to be a geometric derivation of the electronvolt. Now, again, my big thing is, oh my god, if we could just get some of the base units, if you get the fine structure constant, if you could get this, and again, this is conjecture. This is conjecture. I mean, it model does happen to have 2 more confirmed predictions in string theory at this point, the mu1 G2 and the classical electron radius after the SI redefinition. I'm just, I think we got, or maybe we measured it. I don't know. Maybe it was like an extra 2 or 3 significant digits. It was a lot more information. Basically it ended up predicting it, and then, or at least within the error bars, and then it got a little bit more. Excuse me, we found the imaginary goat ratio. I need to do a video just on that, those cards. But yeah, pretty fun stuff. Hey Jax, thank you for joining. Hey Eli, good to see you, my friend. Good to see you. Got some folks from all around the globe and everything here. That's the wonderful part about the internet. You never know who's watching. Because at least in my case, I've been blessed enough to have a lot of really smart folks that are watching now and temporally in the future. Hey, Whitechapel, thank you for joining, my friend. I know I'm terrible at these things. I need to start getting a set time. I don't know. The plan is at some point I might do this full time. We'll see. We'll see if we can make it possible. I love to do things on a consistent and regular basis. It's also pretty fun and fantastic. I also learn a lot. The amount of questions you get and just little insight, just mentioning this one little thing, you take a look, it's like, all right, maybe there's nothing there. Or sometimes you're like, oh my God, that makes so much more sense. Why? I'm just a single dude. But the one thing that I learned about humanity is we're very fascinating creatures, especially when we can come together. I'm not sure there's really a limit on what we can accomplish. But that's just my opinion. But that's all we got for right now. Peace out, everybody. Take care of yourselves. It's a wacky and wild world out there, but I'm pretty sure the light is on our side. I claim. Take care of yourselves, everyone.